Well, welcome back to another monster review session tonight. And I tell you what, every time you work hard on one of these videos and take great notes, I want you to visualize your Regent score going up an additional 2 or 3 more points every night. And that may or may not sound like a lot, but I'll tell you what, if you do that over the course of many, many weeks throughout the entire fourth quarter, then you're going to be extremely pleased with your performance in June on the Regents exam. So anyway, tonight's topic is a rational equation, and it's totally different than what we saw in the video the previous night. Nothing we saw was an equation like it will be tonight. A rational equation is basically an equation containing rational expressions. And rational expressions is what you saw in the previous video. Basically fractions that contain variables in them. And our big key move tonight is to multiply both sides of the equation by the common denominator. A lot of times what I'm going to do is I'm just going to refer to it as the LCD, the least common denominator. And what that does is that eliminates the what? That eliminates the fractions. So that's our big key move. Identify the LCD, distribute that through both sides of the equation, and eliminate the fractions, then we'll be ready to mosey. Alright, my big goal today is, by the time you get done watching this video, I want you to appreciate the difference between these two problems. I want you to copy them down in your notebook, put them side by side, and really analyze the difference. Obviously, the one on the right is the topic that we're going to cover today because it's an equation, because of strictly that equal sign up there. So in this particular one, we are solving for x. We're trying to figure out what number could I substitute in for x to get both sides of the equation to equal each other. However, on the left side, this is what we did in the previous video. This is just a rational expression and we're trying to combine into one fraction. And the big theme over there was that we wanted to keep the denominators. We weren't trying to kill them. We weren't trying to eliminate the fractions. We were trying to keep them and just basically take two fractions and combine them into one fraction. So really, I'm hoping that today you can appreciate the difference between the two. Basically, what I've picked out for you tonight is 3 problems varying in difficulty with different characteristics and things I want to emphasize. Now, what I want to encourage you to do on all 3 of these problems is copy down the problem, try to solve it on your own, and then if you're feeling good about it, you're more than welcome to fast forward to my solution. And I'll tell you what, I have no problem with the fact if you're getting the same solution I am, just kind of fast forwarding through it and so forth. But otherwise, if you have any moments of hesitancy, then strictly play through the video in its entirety and see if you can pick up a few little things that I want to point out and emphasize. So on the left side here in red, I've kind of made a checklist of things that are going to run through my mind. Number 1, I'm going to identify the restrictions on the domain. In other words, what that means is I'm going to look at my denominators, and because our denominator is not allowed to equal 0, I'm going to ask myself, what is n in this case not allowed to be? And so because they're just monomials here, I'm going to make a note here that n is not allowed to be 0, because if it was, it would make these denominators 0 and so forth. The advantage of that is it's going to help us when we get to our solutions at the end recognize any rejections that need to take place. So step number 2 is I'm going to identify my common denominator. My common denominator in this particular problem is 2n squared. So I'm going to line that up. I'm going to take my 2n squared. I'm going to distribute it through. And I'm going to go in slow motion here. I'm going to show the distribution to each term, which is a little redundant, but I think if you're not having a ton of success on this particular topic, this is really going to pay off. You get our multiplication signs in there. 2n squared over 1 times 1 over 2n squared. Alright, so here's what it's looking like right now. What I'm going to do here is I'm going to say n squared divided by n squared is just a 1, and then multiply 2 times 1 is 2. Let's say, whoops, that's not supposed to be a squared, is it? Okay, pretend that's not there. Let's say that n squared divided by n gives me an n, so as I multiply across, I get 2n. And then over here, they completely canceled. 2n squared divided by 2n squared was 1, and so it just equals 1. And do a little algebra here, and n equals negative 1/2. Alright, now we got to work on, we just solved it. Now we need to work on the checking part. Grab those calculators, and let me show you how we're going to do this. So with regard to the check, this is what I'm looking for tomorrow in class. What I did here on the left-hand screen, and you can see it faintly here, was I took my solution, negative 1/2, I stored it in A instantly. So get the storing done. Once you store it, what we're going to do is we're going to type in, and I think you can see it over here on the right-hand screen a little bit better. You're going to type in the left side exactly the way you see it. If you have the 84, take advantage of alpha F1. Use your fractional symbol. You can still do it on the 83. It's just going to look a little different. And type in the left side. and then you hit enter and you got a 2, and then we type in what's on the right side of the equation, exactly the way we see it, and then we hit enter. As long as these numbers are a match, we have a successful check, and that's exactly what I'm looking for in class tomorrow. One of the things that the Regents exam is famous for is they try to throw in as many minus and negative signs as they can. Statistically, the more they put in there, the higher risk there becomes in us trying to solve it. But first of all, identify your restrictions. I'm going to look at the denominators. I'm going to say there's two things x cannot be. X is not allowed to be 0 because of the first denominator, and then we're going to say x is not allowed to be -1 because of the second denominator right there. And so what happens is we're going to just put those on our paper, and if we end up getting 0 or -1 as a solution, it's going to be an instant rejection because of those restrictions on the domain. The next thing I'm going to do is I'm going to identify my common denominator, which in this case, I'm going to use both the 2x and the quantity x plus 1 together as my common denominator. That's what I'm going to distribute through. Again, I like to show this step just for just to ensure that we all understand what's going on. I'm going to show my distributing all the way through. And let's see, I got 2x, x plus 1 over 1 times 2x over x plus 1. So strictly encourage you, if you haven't tried to solve this already on your own, I really encourage you to hit that pause button, see if you can finish this one all on your own. And watch this last term. I'm going to put -2 over 1 just to emphasize where the numerators are. And now I'm going to go ahead and I'm going to clean this up the best I can. For instance, I'm going to say 2x divided by 2x is just 1, and then we'll distribute the 3 and get 3x plus 3. Notice the denominators are now dead. We could say x plus 1 divided by x plus 1 is a 1, and don't forget the minus sign there. And last but not least, nothing cancels. So here's what I'm going to do. I'm going to distribute the 2x first. And what that's going to do is that's going to give me, what's that, 2x squared plus 2x. And then I'll distribute the -2 to get -4x squared minus 4x. Now we just got to solve it. It's very simple. If I add 4x squared to both sides, that term cancels that term. I'm going to also add 4x over here to get 7x. Whoops. Meanwhile, I'm going to subtract that 3 over, and I'm going to end up with x equals -3/7. Again, I'm going to store that in alpha A, and I'm going to plug each side in individually and see if they equal each other. And I'll be back momentarily to show you what my calculator looks like. So here's my calculator screen. I took my solution, -3/7, typed it in, I stored it in alpha A, and then I went to town, alpha F1, I put in all my fractions. As soon as I hit enter, I got -2. And this is an odd one in the sense I didn't even need to type in the right side because the right side was already strictly -2, so we did get a perfect match and this solution checks. All right, 2 down, 1 to go. Now, our first step is don't overlook this first step. It's a tough habit to build, but we have to build good habits. We have to identify any restrictions on the domain. And the one thing you might want to do before we even jump into that is to factor that first denominator as much as possible. We're going to pull out that little GCF. And so our new denominator there is x times the quantity x minus 5. So I'm going to say there's two restrictions. X is not allowed to equal 0, and x is also not allowed to equal 5. So if we do end up with either one of those solutions, we'll put a rejection on it instantly. So next thing we want to do is identify our LCD, which in this case is going to be both x and the quantity x minus 5. And again, I'm going to be very redundant and just show my distributing all the way through here. So we've got this times over 1 times 1 all over x quantity x minus 5. So here's what mine looked like when I got done distributing the x and the x minus 5 to each individual term. On this very first term, x cancels x and the quantity cancels the quantity, so we just have a 1 left. Make sure that you don't accidentally put a 0 there. On the second term, right here, we're going to say x divided by x is just 1. Now, as we multiply what's remaining, we're going to have to FOIL. So I've got x squared plus 7x minus 5x. We'll combine those two terms, minus 35. And then on the last one here, I took the last term 1 and I rewrote it as 1 over 1. Nothing cancels. We have to distribute the negative, and let's put a little asterisk in our notebook and just highlight the idea of distributing the negative through there. This little rascal, so it's going to be minus x squared plus 5x. And that last plus sign there in front of the 5x is probably the most crucial point of the problem. As I begin to combine like terms, I'm going to end up with, nope, scratch that. These x squareds cancel out, don't they? And also you'll notice the 5x cancels, so all I've got over here is 7x minus 35. We'll add the 35 over, and then we'll divide by 7. So 36/7 is my solution. I'm going to store it in alpha A, and I'm going to plug it back into the original equation. Left side, hit enter, then type in the right side, hit enter, and make sure we got a match. So looking for some very exquisite, well-detailed work tomorrow, and I'm hoping we're ready to step up to the next level.